Hey guys, what's going on? Good morning. This is like my third or fourth time trying to make this video. I really think I got it done this time, so hopefully this works out well. I'm sure if you guys watched me try and make this the other three or four times, you would have laughed at my frustration. Uh, but I'm gonna try and go slow because I've repeated the same information a bunch of times. All right. So the standard normal distribution. Okay. So this is a picture of a standard normal distribution curve, often called a bell curve. So we're gonna be working with this so we can go through this normal distributions worksheet 12-7 that's on the website. Um, so don't, first of all, I don't know why. These should all be decimal points. These are decimal points. That's 0.1%, 2.1%. Okay, I don't know why they're not. So information is normally distributed. First of all, typically you need a fairly large sample, right? Because we want to have like all these numbers and things like that. But also it has the same mean, median, and mode. So we talked about that. So again, the mean is your average, right? If you took all your data together, added it, and divided by the number of entries. Your median is if you ordered it from lowest to highest. Right here in the would be the what splits it right down the middle, and the mode would be the thing that occurs the most times. So a simple example that we're going to talk about today is height. So we'll talk about height of American males who are 18 years of age or older, just because it had the simplest numbers. Not discriminating against the ladies. It had decimals, so unless you guys want to do decimals, we're going to stick to the guys for today. Okay, so men in America have an average height of 5'10". Okay, so 5'10". So because height is something that's normally distributed, it has the same mean, median, mode. So in other words, if you made every man in America the same height, it would be 5'10". What's the most often number that occurs with height? 5'10". And again, if you ordered every man from left to right in America and you said, who's the guy in the middle, that guy would be 5'10" tall. Okay. So that is our mean. Okay. 5'10", and oops, 5'10". I'm also going to write that in inches because that might help some of you guys. Okay. So that's 70 inches because we have a silly way of measuring things. Okay. So that is the thing that occurs most. And again, if we had a little bit bigger than that, like, 6 foot to, it would be about here, right? It would be most people, it would be in that height, okay? As you went up with your height, as you went higher than 5'10", you'd have less and less people. As you went lower than 5'10", you'd have less and less people. Now, there's a thing called a standard deviation, which is this little guy right here now. This is sigma. This is actually lowercase sigma, and that's going to be standard deviation. Standard deviation is a set number away from your mean, right? Or your mean, your median, your mode all together. We just call it the mean when we're dealing with this. What we're saying is that if information is normally distributed, and we'll go over how to calculate a standard deviation and what that means. When information is normally distributed, what that means is within one standard deviation above, 34.1% of people should occur, or in this case, men. And below one standard deviation should also have that same amount. And this again has to do with that mean, median, mode. So the standard deviation for height is, in this case, going to be 4 inches. Okay, so what does that mean? That this is going to be about 74 inches, which is 6'2". And below would be 66 inches, which would make about 5'6". Now, what this is saying is that if we put this 34.1% together and this 34.1% together, then we would have about 68.2% of people. That's more than 2/3. So think about the men that you know in the world. Would you say that about 2/3 of them are between 5'6" and 6'2"? Yeah, probably. So if this is average height, these are the guys who are a little bit shorter and a little bit taller. If we went on to second standard deviation, we'd be at 78 inches, which makes you 6'6". And if you went out this way, you're going to be about 62, or about 5'2". 2. Now, that's 95.4% of people, meaning if you took 100 people in a row, 95 or 96 of them would be between 5'2" and 6'6". Now that, by the way, is a pretty big spread. I know that sounds like a huge percent of people, but it is. I mean, if you think about it, 5'2" are people who are generally pretty short, and 6'6" are people who are generally really tall. Just put that in perspective. I know you guys think I'm like the tallest person in the world. I'm 6'7", so I'm a little bit outside here. So I might be the one person, one of these 6 people, or one of the 4 people outside this 96% that is a little bit taller, a little bit shorter. Okay, but again, we go out 1 standard deviation further to 3 standard deviations above and below. That's 6'10" to what is it, 82, and going down this way, that's 4'8" to 58 inches, right? Now, that's 99.7% of people. That's essentially, if you had 100 people, everybody, there might be one person who's a little bit taller or a little bit shorter. Okay, you need a large sample size in order to actually have some of these people typically, right? Now, these are people playing in the NBA, and these are people who are riding horses for a living. These are jockeys. These are basketball players, okay? These are the people who are exceptionally short and exceptionally tall, okay? Now, are there people shorter than this and taller than this? Of course there are. And in fact, there are more than 3 standard deviations. There's 4 or 5 standard deviations going up and 4 or 5 standard deviations going down. The standard deviations keep going. The idea, though, is that just you would need a big enough sample size to encompass them. Like I said, outside of 3 standard deviations above and below, we're at 99.7 people. So if you had 100 people, chances are you wouldn't have anybody here. Now, if you had 1,000 people, you might have 3, right? So those other people way out here, again, if you kept going, is there someone out there who's 7'2"? Of course there's people out there who are 7'2". And that would be 4 standard deviations, right? That would be out here. But again, that is less than 1% of your population. So you need a big sample size in order to make that work. Are there people who are shorter than 4'8"? Are there people who are 4'4" and below who are, short? Sure, of course there are, right? And again, once you get past these things, you're talking about people who probably have, some type of genetic thing that's going to make them exceptionally tall or exceptionally short, right? Those again. Are there people who are taller than 7'6"? Yeah, there are. Are there people who are shorter than 4 feet? Yeah, there are. But again, you're talking about a very, very tiny percent of the population. And again, even I've seen like statistics type books, once you get to 5 standard deviations, they don't even give you the numbers anymore because you're at 99.9999% of the population. So we'll talk about that a little bit as we go through, but this should give you a general idea of how standard deviations work when they're normally distributed, okay? So, long story short, real long story short, right? Going through our time here, we're at 8 minutes. Long story short, this is just adding and subtracting, right? If we think about this, all we did for this information is we took 70 inches and added 4, and we subtracted 4. So this is something that we can all do. So essentially, all we really want to be able to do is add and subtract, and we'll talk about what we're going to do with those numbers. Essentially, we're going to take them from percents, and we're going to represent a population. If we had 200 people, how many would be above this height? So let's take a look at a couple of questions I want you guys to be able to do. Again, this is on the website. This is the one labeled normal distributions 12-7. So it says a set of data with a mean of 45. All right, so before we even get to the standard deviation, the mean of 45. So the mean for this data is 45, okay? And a standard deviation of 8.3 is normally distributed. Find each value given a distance from a mean. So 8.3 is your standard deviation. So all we need to do from this 45 is add 8.3 and subtract 8.3. So I'm going to break out my little calculator. I have to install the fancy one on here. Where's my calculator? So all we're going to say, oh boy. Sorry, I'll make this one a little bit bigger. This one makes it a little bit smaller. Yeah, let's try and do it that way. I'll hide this, make this a little bigger. Okay. So 45 plus 8.3. That's it. One standard deviation above, you're going to be at 53.3. Okay. Let's add another 8.3. And we're going to be at 61.6. So 2 standard deviations would be 61.6. And let's add one more. We're going to be at 69.9. Okay, going down, we're going to do the same thing. We're just going to subtract 8.3 3 times. So say 45 minus 8.3 is going to be 36.7. Let's subtract another 8.3 from that number. We'll be at 28.4. And if we did it one more time, we'd be at 20.1. Okay. Okay. So it's a little more like 36. Okay. So what do they want to know? Oops. Sorry. What do they want to know? What's 1 standard deviation above? 53.3. So plus 1 standard deviation would be what? 53.3. Plus 3 standard deviations. Plus 3 standard deviations, we say, well, here's plus 1, plus 2, plus 3. So 3 standard deviations is going to be 69.9. Minus 1 standard deviation, 36.7. And minus 2 standard deviations, again, we're going 1 standard deviation, 2 standard deviations, 28.4. Okay, so again, what are you going to do? You're just going to add and subtract. Again, if you didn't want to fill out this whole thing, well, you could say 45 minus 8.3 minus 8.3 again. You can get this number. Okay. For here, you can subtract it 1 time. For here, you could have added it 3 times. Okay. All right. So I am going to do, I don't know, maybe probably just one of these. I mean, I'll do 2, just to show you guys that this is pretty straightforward. So sketch a normal curve for each distribution. Label the x-axis at 1, 2, and 3 standard deviations. Yes, this is still the x-axis going across. Okay. So what's your mean? Your mean is 95. What's 95 plus 12? Well, that's going to be 107. What's 107 plus 12? That's going to be 119. What's 119 plus 12? That's going to be 131. Okay, so again, what I did, I added 12, I added 12, and I added 12. Going down, if I subtract 12, 95 minus 12 is going to be 83. 83 minus 12 is going to be 71. 71 minus 12 is going to be 59. Okay. For the second example, again, what's your mean? Well, that's going to go right here in the middle. That'll be 100. Okay, again, adding 15. Adding 15. Adding 15. Again, 100 minus 15. 85. 85 minus 15. 70. 70 minus 15. 50. 5. Okay, so you guys should be able to do the next few. Just go ahead and just fill in the numbers. You can use a calculator if you want. So yeah, I know everybody hates decimals. Use a calculator. It's fine. Okay, and then what we'll take a look at over the next few days is how we're going to apply that. If you had 230 tests, how many people scored above or below a certain grade? And number of lengths, number of nails in a given length in a bag. Okay, so again, we'll go over how we're going to apply these things. Okay. Just so you guys know, you can break down this curve a little bit more. And that's really, in order to do that, we're moving away from statistics and we're getting a little bit more into calculus. But what if I said I wanted a half a standard deviation? Could you? Absolutely, you can have a half standard deviation. Again, and it would represent something like this score right here, right? Could I have a quarter of a standard deviation? Yes, you could, right? And again, once you start breaking those percentages down, half and quarter and eighth and a 16th, you're going to get different populations. Now, they're not going to be as big as this 34.1, but we can say that, again, right around this. So if we were talking about our height that we were beginning with, that standard deviation was 4, well, what if we said we want to split that in half? What if we wanted 70 inches and 72 inches here and 68 inches here? Yeah, that would be proportionally a bigger percent. What if I wanted to go between 69 inches and 71 inches? Again, that might be only from here to here, so that's going to be even more people. So just so you guys know, yes, you can break them down further, and there are assigned percents for every single one of them. If you guys take statistics, you will go through z-scores and tables and things like that that will explain how to find those things. So anyway, I hope this helps. Try and do these next few examples on this paper, just 7, 8, 9, and 10, and we'll talk about the rest of them tomorrow. Okay. Thank you guys very much. Hope everybody's doing okay and everybody's safe. I'll talk to you later.